So let's continue, and from this video we will start our momentum roughness length development, which will be part of sensible heat flux. So let's create a new file within the repository of Cibal, and you can call it just like I called, or you can call it more elaborate, the momentum roughness length. And let's import our asset farms here using this one import. And assign it to variable, name it forms, and also let's import our geometry, which we just created in the previous net radiation flux script. You just can copy, just click here and copy geometry 1, and let's also import the file future collection and United Arab Emirates shapefile. So now, and we will start our the import of land use land cover classification. Let's create dataset Korean image collection. So we will import this this dataset, Copernicus global land cover layers with the 100 meters resolution. So it's earmarked as a component of the land service to operate a multi-purpose services component that provides a series of biogeophysical projects on the status and evolution of land surface of global scale. So let's select this one, classification. So there are multiple bands here. Discrete classification, land cover classification, discrete classification probe, in percent quality indicator, forest type, bare cover fraction, etc. But we don't need this one. We need only discrete classification. It's not an image collection, by the way, it's an image. And next step is to create variable lc value Korean get now we will get names, properties, this one. So we will select property, not a band now. So discrete classification names, and print class names lc. Run. So this is the 23 classes of 23 classes of land use land cover string, and we will create now a new dataset var all areas Korean clip to collection, clip to collection, United Arab Emirates, rename, Korean classes. So it will clip the image to a future collection, map, add layer, geometry, Corinne. So we can check, run, geometry 1, sorry. So this is all classes, Corinne classes, and cover classes for the study area. We can just go here and go to stretch. We see that not all classes exist here. We can go to bands, and this in here this classification class table, you see the value and color and the description of a class. It starts from 0, it's unknown, 20 shrub, 30 herbaceous vegetation, this is 115 closed forests, 125 open mixed forests, etc. So not all classes exist here. So our next step is to extract classes from the relevant classes for our shapefile geometry. So in order to do this, we will create a list, and we will just need to create objects of the list with these values. So I copied all the digits of classes from 0 to 200. In general, it should be 23 classes, I guess. 23 classes. So, and next step is I will create a list, and I will create a function and map this function through the list. So I will create list index of for each index of the list, so areas, all areas equal number integer multiply image pixel area divide 10,000, the area of the pixel, because it's in 100 meter pixel resolution. So reduce region, reducer, there rates, scale 100, maximum pixel, now return areas, get number, Korean classes not equal to 0. So this is a condition, if you remember. This is a condition, and now this is, I will express the result of the true. If the condition is true, it will return a list. Get Korean classes. Second, the element of the number of a class, it means value, and the third is list lc value, and the object idx. So otherwise the false condition will be 0. And I will remove all zeros. Doesn't read reducer. It's a dot here. Sorry. Let's save it and run. So it's strange why it shows an error. I think the reason is that I wrote image instead of image collection, because it's actually image collection, but the problem is that it is written here image, but here it's written image collection, so it's inconsistency. So in this case, let me also select first. Now let's run again. It's max pixels. Again, mistake. So I fixed the image. I was incorrect writing of this area. Unnecessary semicolon. So this function here, reducer, computes the total area of all classes which is present within this geometry in square meters, and it returns as a, if the condition is true, it's not equal to 0 Korean class, it will return a list which contains 3 objects: area, a value of a class, and index, actually the name of the class. So let me just put this description here, because it's for this function. Run. No. So run now. So it returned I forgot to add the map add layers, or print, sorry, print areas. Now let's run. So it computes areas. So see that only 11 classes exist. So this is the area of a class, the value of a class, and the name of a class. Area, value, and the name of a class. And the last one, area, value, and the name of a class.